life and give you eternity, eternal life. In a Hellenistic tradition and an Islamic tradition, alchemy was mostly close to what we know as chemistry, but their aim was how to transmute elements, to change, I don't know, copper into gold. The Eastern alchemy coming from India and China seeking for elixir of life didn't find a right place in Islamic culture, in Christian culture, because it had a clash with their religious belief who can be eternal, not a human being, obviously. And they didn't practice that type of alchemy. They mostly worked on chemical alchemy, the one that we know. And what happened in this field, they tried to, first of all, create a theory of matter. So uh, some of these alchemists that you see, they were really great people. They were scholars of the time. And they were not that stupid to, I'm sorry using this word, to just waste their time to transmute elements. They had a theory. They were thinking that, okay, in a sublunar region, everything is made up of a combination of four elements. And we will see later in 16th century, a German alchemist, Paracelsus, we already briefly talked about him. He introduced new three elements, which were three elements. They tried to investigate nature more and more in this way, that how can we change the combination of these elements and create new elements. In one hand, we had people coming from Aristotelian ideas. In the other hand, we had people coming from atomic ideas. They were thinking that everything is made up of the same atoms, but in different arrangements. And if we can break this arrangement and put them in new arrangement, we can create a new material, new substances. To do all these things, they had to do experiment. They had to perform all these things in a lab, in a chemical lab or alchemical lab. They had ideas coming from ancient world, from the philosophers of or scholars of Hellenic and Hellenistic period. They were thinking that there is something called philosopher's stone, that if you rub it to anything, it changes it into gold. They had a person, what's called a mythological person called Hermes Trismegistus, or Hermes three times great. And many writings were attributed to this person, Hermes Trismegistus, and a lot of occult writings, about a lot of magic writings, that they had to decipher them and then make a great what called discovery in chemistry and in transmutation of elements. The same stuff traveled into Islamic territories, and they created their own alchemists with a lot of writings. And all these things were translated into Latin later, and they continued the same tradition. In this way, they were able to create a lot of things. For example, in Islamic period, by distillation of wine, they were able to create, for example, alcohol, extract alcohol from wine, and they made something close to probably cognac or vodka in modern literature. And they practice it in other liquids that they had. And in this way, they were able to know about the nature of acids, nature of bases, and they tried to identify more and more elements which by that time, obviously, they didn't know about the structure of elements. They knew that it is just made up of itself, like gold, like iron, like lead, and how to find about compounds. it is also a time that there were a lot of practical aspects of alchemy, how to make dyes for fabrics, for silk, how to um, make the best ink for the new technology that we had, printing press. So make ink durable on paper without spreading it into the fine structure of the paper, and create a durable, well-defined ink mark on paper, and many things like this. Also, we see that in some courts, like Medici court, they spend a lot on alchemy to cut the monopoly of Chinese in making porcelain, and how to give a glaze on porcelain. And all these actually activities, nowadays we think that they are non-scientific activities, but all somehow were connected into scientific activities. They couldn't make gold, obviously, but they made a lot of other discoveries which craftsmen and other industries used them. One of the people which uh, created a new type of philosophy about alchemy in 16th century was Paracelsus. Paracelsus was a doctor, a chemist, and he had a long name. I'm glad that he picked a Renaissance name, Paracelsus. His name was Theophrastus Philippius Aurelius Bombastus von Hohenheim in German. And he introduced a type of mystical idea to connect the macrocosm to microcosm. So you think about all these things in a completely religious setting. You think about this in this way, that God created the entire universe, and obviously everything is the creation of a single mind. And there must be a lot of connections between what happens in celestial region and what happens in terrestrial region. And this yield to a concept that's called the doctrine of signature, or how to connect uh, celestial affairs to terrestrial affairs. And they tried to connect somehow even the function of the body into what's happening in astronomy. Last week we talked about that, the connection between zodiac and body parts, the organs in our body. And this person, Paracelsus, also introduced a new non-Aristotelian idea about elements, because he was an alchemist, and alchemy, they used a lot of salt, sulfur, and mercury. And he introduced this tria prima as main components of alchemy. Again, it is scientifically speaking, it is not that important, but what is important is deviation from Aristotelian, from classical ideas, and coming up with new ideas. Out of all these practices, we see that a lot of publications happens in, not in scientific field, but in crafts, in what in application of science, or practical fields, like metallurgy. For the first time, we see that Agricola writes a book about metals. He talks about ores, how to classify them, how to distinguish them, and then how to process them, how to smelt them and make stuff out of that, talking about alloys, which we didn't have any background in this. As a independent publication, you can find about ores and about metals in other natural history books, but it was the first time that we see crafts knowledge spread through the publication with the availability of printing press. all Libavius published about alchemy, about the principles of alchemy, and it was not a part of university knowledge, university curriculum, and then by these publications, people try to practice them, and in this way, the knowledge of chemistry uh, spread. And then another publication, which actually originated from technology and then found its way into pure science, was about magnetism. This is a period that navigation revolutionized in Europe. Europeans learned about magnetic needle or compass from Chinese, and it happened almost the same time that Ottomans expanded and blocked the connection between Europeans and East. Then Europeans had the only way to go and make trade with East was setting the sail and traveling on the ocean. And this time they revolutionized the knowledge of navigation by combining magnets, the magnetic needles, the compass, and spherical trigonometry, astronomy, and geometry, and cartography, making of map. And little by little, they discovered that Earth was like a great magnet. He found about the declination of the magnetic needles because they traveled everywhere, and they recorded the direction of magnets. And by the beginning of 17th century, they found that the magnetic pole and a geographic pole are not the same. So they considered the Earth as a big magnet, and the first full book, independent book about magnet and its impact and its the distribution of magnetic force around the Earth, published in 16th century by Gilbert. You see here, Gilbert is presenting his book to Elizabeth, the Queen of England, and this is the title of this book. And it was an introduction of a greater idea about some central forces acting in what we now call it the solar system. Last time, we briefly talked about Kepler's discovery of variation in the speed of planets, and to have a change in speed of planets, you need a force acting on them. And this idea immediately was accepted by Kepler, and he thought that there is a kind of spirit. He doesn't use this term, modern term that we have as force in explanation of planetary motions, but he uses this term, spirit, a magnetic spirit, filling the planetary system. Again, I'm not using the solar system because this term appeared later. So all these activities happening in what from the end of 16th century to beginning of 17th century. And day by day, we discover new stuff. And we find out that there are other ways to discover stuff besides the practice that we had in medieval and early medieval periods. So the dominant philosophy was Aristotle's philosophy. So you had your observations, your experience, your generalizations, and categorizing everything and acting as what a person, if you were a scholar or scientist at the time, how to describe nature as it is. You just take a snapshot and explain whatever you see and try to justify or explain why the things are the same as we see. Okay, here, because of all these new discoveries and new ideas, we needed new philosophies in science, new approaches how to make discovery, how to create a rationale about nature, how to interpret nature. And one of the first philosophers we see uh, introduced a new way to make scientific statements was Sir Francis Bacon. Francis Bacon was a statesman and philosopher, and he wrote two books, among other writings that he had, very important books, New Atlantis and New Organon. You can find them online in Internet Archive, free, and you can read them. They are very small books. And there, he lays down the philosophy that we call it the experimental philosophy. How did he reach to this point? He started introducing or describing the system of thinking that we have, the system of philosophizing that we have about everything. He introduces four tribes, four idols. By idol, how do we define idol? We create something and then we worship it. So we worship something that is outcome of our own production or ideas. And he says that, okay, we are in a loop, we have to break this loop and come up with some new ideas, some new approaches. He introduced this idols of tribe. No need to memorize all these subsections of these idols, but idols of tribe comes from the humanities' psychological and physical limitations. And idols of cave are limitations by education and society that we have. Idols of marketplace, ambiguities from the nature of languages, how we communicate and understand each other. And the idols of theater are intellectual systems that control your thoughts. So he says that how can we modify them or get rid of them? Obviously, we have some physical and psychological limitations. How can we improve them? Okay, or eyes or hands or I don't know, body have limitations from the viewpoint of force that we exert or things that we see, how far we can see, how small stuff that we can see, any way that we can modify them or improve them. How can we use science to create, in again modern terminology, technologies to improve our abilities? He strictly talks about how to use knowledge, theoretical knowledge that we have, for example, improve or in inventions. He talks about, for example, how to improve the power of gunpowder or improve the range of projectiles that we have, how to bring science and technology close to each other. We know that up to 18th century, end of 18th century, science and technology were two different activities. We didn't have I don't know, polytechnic universities to teach for to produce engineers, to educate engineers. 7 liberal arts in all universities, they were doing their own job. You know about the curriculum. And technologists or engineers, they know about the field from different sources, mainly from master-apprentice relationships or the knowledge that they had in their guilds, in their unions. There were only probably two fields you could find a connection between theoretical knowledge coming from universities and engineering. One was in timekeeping devices, how to make clocks, how to make sundials, because you needed a very good understanding of celestial motions, specifically motion of the sun, and translate that astronomical knowledge into a technological piece or device. And the other was in architecture, in design of the places that you had to know geometry very well. And after this design process, the rest was the business of what skillful masons. They knew about the type of stones, the type of materials, how to join them, how to put them together. And they had this knowledge coming from what? Trial and error, from the experience that they had in their guild or their union or their family. And we didn't have, I don't know, scientific knowledge of strength of materials that appeared later. We're going to talk about this today when we are talking about Galileo. So this is the approach that Sir Francis Bacon had. And one of the most important ideas that he developed was how to learn about nature more by performing experiments. So let's finish this slide about the idols. Idols of K, the educational system in society. What do we learn from universities? Are they perfect? Can we change them, modify them, and bring new ideas, new educational systems? In New Atlantis, actually, he introduces what we can consider it as a modern research institute. Institute that you perform experiment to collect more data, and then by analyzing that data, you come up with some hypotheses, and then make predictions, then do experiment, verify it, and then come up with theories. In Idols of Marketplace, he talks about the ambiguities coming from the languages, the concepts that we have. The way that I'm thinking about force in my own language, is it equal to the same concept that you have, the same thing that you learned it from your own culture with your own language? Or are we thinking about the same concepts the same way? What is the difference between them? Then you can practice it in this way, that I'm sure I have a lot of bilingual students here. If you are bilingual, then think about some important concepts in your mother tongue and the language that you learned later. So I had this chance that to learn a few more languages. My mother tongue is Turkish, and then I learned Farsi or Persian language when I was 4 or 5 years old. Then we had to learn some Arabic. Then I learned Arabic more because I had a project to find out that we already talked about this, the connection between Copernicus and Arab astronomers, and I had to read their books in original language. And then I had to learn English when I started from, I don't know, 12, 13 years old. And then in my graduate college, I had to learn French and German because we had to pass proficiency exam in these two languages. Then I'm not fluent in French or German, but I can I don't take care of some stuff to read and understand with dictionaries. But when I'm thinking about some concepts that I learned in my mother tongue, and then later I learned the same concept using a different language and different language in different intellectual atmosphere, then you find out how things can be different. If you are interested in this field, you can study the writings of Ludwig Wittgenstein, one of the greatest philosophers that we had in 20th century, and he talks about this, the relationship between language and understanding. Or for fun, you can put a sentence in Google Translate and translate it back to back in languages that you know, and finally you find out that, okay, the last translation that you have has no relationship to the initial input that you had. Anyhow, this is a fun part, but at the same time, very interesting part of the difference or the relationship between language and understanding. He talks about this in the idols of marketplace, and finally the idols of theater. He talks about intellectual systems that control our thoughts. So imagine you were in 17th century, 16th century. What was the dominant philosophies or controlling system in your knowledge? Obviously religion and Aristotle's idea, and you were thinking inside that box. So again, practice this way, that you live in 16th, 17th century, and you think about the universe. You're at the center, everything is moving around. This is what the dominant philosophies and doctrines that you have, and you think about the role of God here, and all related things that made your worldview. Sometimes I make joke of this and say that, okay, we have a similar thing right now. If I ask you something that you don't know, none of you, and also I'm not, I don't know anything about this. Imagine I learn a new word, okay? What is the first thing that we do about this new word? We go and Google it. And our knowledge about that word is the first line of the first page of Google. And we don't go further. And that shapes our understanding of that specific word or concept. So Bacon talks about this, how to improve this, how to come up with new idea which matches better with a real understanding of truth outside. So he asked this question from Aristotle, that Aristotle says that, or syllogism or logic works in this way, that we have categories, we have the definitions of all these categories, and then we make a conclusion based on those pre-established general facts. Like what you see on top of this slide, that there is no change in celestial bodies. Okay, you can ask Aristotle, did you check every single object in the sky to reach this point? Whatever that we can see and whatever we cannot see, you can use the syllogism in some fields that you are 100% sure. Like what? The syllogism says that all men are mortal. All experience that we have, from the fossils to the present day, that we didn't have anybody living more than, I don't know, 120 years. Then everybody dies. and we searched everywhere, we couldn't find. Then you can say, okay, Socrates is a man and Socrates is mortal. But in some cases, you cannot generalize that way. And when you cannot generalize that way, you cannot use the syllogism at all, because you are not sure if you observed all single cases to make this general statement. So this approach is called what? Deduction, going from general to specific. Bacon toppled this. He actually introduced a new approach, how to increase the observations. And after having many observations, you make a generalization out of that, and then make a statement, a general statement coming from too many observations. It is called induction. Okay, so how do we practice science right now? Can we prescribe a baby aspirin just by saying the statement that aspirin is good for people? No. You start from thousands of experiments, starting with mice, then I don't know, monkeys, and then selected group of people in different ages with different conditions. And after thousands of rounds of experiment, you come to this conclusion that I don't know, baby aspirin 81 is good in such and such conditions. Even you put some conditions there, and you cannot generalize it in that way. I probably use this example. It is my favorite example, that imagine you are an alien landed on the earth, and you want to make a theory of human being. You enter into one of classrooms at UCR, and you see a bunch of people sitting there, and then you want to make a theory of human being. How can you start? You have to observe. By observation, I don't mean just looking. In a general way, you do all kinds of measurements. Imagine you have X-rays, you have MRIs, you have, I don't know, scales there, you have spectrometers. You do all types of observations about human being, and then you ask a lot of questions. You can ask questions from, I don't know, the brand of the t-shirt that I have, to the question that why this guy talks all the time and everybody's silent sitting there, to many questions. But your aim is to create a theory of human being. Then by analyzing your data, you come up with that, okay, the maximum size of these people is such and such, the minimum size is this, the maximum weight is this, the minimum weight is this. Colors, you see black and white, and what in between, you cannot find, I don't know, purple people. And from the physics or the X-ray images or MRI images that you take, you find out that most probably human being comes in two forms. And then you put them together and you make what we call it educated guess or a hypothesis. The next step is what? How to verify if this idea, if this educated guess is okay or not. Then you make a prediction out of that. If this hypothesis is correct, then if I go to another community, another group of human being, then I should see pretty much the same thing. And okay, you travel, go to London, do observations there. Statistics may change, but the principles remain the same. Travel to, I don't know, Japan, again, statistics may change, but principles are the same. And in this way, you come up with a generalized version of I'm sorry. Okay. Let me share the screen. Something appeared here, which, do you have my screen? Yes, in chat. Yes, okay, good. Okay, folks, so uh, this is the type of new approach which started to appear in Europe. I don't say that everybody accepted immediately, but we will see that this type of scientific discovery, little by little, became a common practice in Europe. And that's why we see that by, for example, 17th century, we didn't have a place anywhere in this world named, I don't know, physics lab. We had places to practice alchemy, but to understand physical world, to understand better about motion, about free fall, about strength of materials, we didn't have a place named lab. But we see that from the mid 17th century, places appear in Europe how to come up with educated guesses and then verify them by performing experiments. This experimental philosophy was established and created by Sir Francis Bacon. Before Bacon, we had another British philosopher, Grosseteste, which in 14th century, 13th, 14th century, he actually introduced the same idea. He said that, okay, we have to learn more from practicing thing by performing what we call it experiment and increasing our knowledge. Now, let's keep this here, and then we're going to come back again to this approach, to this new Baconian approach later when we are talking about Galileo and uh, his era. 16th century also witnessed a lot of new ideas in religion. So we had Reformism, the rise of Protestants, the rise of Martin Luther, and then other sects appear like the Jesuits. They had their own actually community, their own group, which one of their specifications was how to use science, how to use mathematics and scientific discoveries to understand universe better. We already talked about this, that in classical era, in early medieval period, we had a very harsh hierarchy among scholars, philosophers, and religious authorities. They were on top. They were eligible to talk about the firmament, about the entire universe, about the structure of the universe, and so on and so forth, and discover the, I don't know, philosophical principles in this universe. But we see this idea emerges little by little. And last time we talked about that, the concept of philosopher engineer, that mathematical knowledge should not be considered inferior to natural philosophy or philosophy, because when you discover about the mathematics of universe, actually you discover about a part of universe which laid down by creator, and you discover its mathematical language. It is the great saying of Galileo that God created the universe with the language of mathematics. So this approach is very important here. Why? Because we see that this authority of science, the people who were eligible to come up with new ideas about big stuff, big ideas about the universe, little by little change from pure philosophers and religious authorities to people who practice mathematics or astronomy, and they discovered general mathematical rules in the universe. One of these people was Johannes Kepler. We already talked about Johannes Kepler, who discovered what? The three laws of planetary motions. Jesuits were very active in this field. They taught astronomy, mathematics, and actually they were men of missions. They traveled everywhere. They traveled as far as China to impress Chinese with Christian science. So they went there with all new discoveries that he had in mathematics, in astronomy, in, I don't know, having printing press, traveling there with their telescopes. And when they talked to the emperor of China, they said, okay, we Christians made all these things. And they used actually new sciences as what fact to impress their audience. And we see that a lot of modern scientists were Jesuits. So one of the people who followed this idea, the idea that mathematicians and astronomers cannot be considered inferior to philosophers, natural philosophers, was Johannes Kepler. Johannes Kepler was a student and then assistant to Tycho Brahe. We already talked about Tycho Brahe. I just summarized his contribution that Tycho Brahe discovered that supernovae and comets were not terrestrial, they were celestial, and he discovered it just by mathematics, by using a simple observation and then using mathematical knowledge, and then crashing a part of philosophy or cosmology coming from a great philosopher like Aristotle, and the idea of Aristotle was accepted by what religious authorities too. Then this was the beginning of a very important change in science, a practice of science. You discover a mathematical rule or law in nature, and then you are now talking about the entire universe, about a universal law, and you are talking the same way that philosophers or physicists are talking. So in the first 3 decades of 17th century, one of the most brilliant figures which established many things in modern science, specifically in modern astronomy and modern physics, was Galileo Galilei. So Galileo studied at university, in Padua University, studied medicine and then mathematics and astronomy. And after a while, he left university and became a court mathematician and philosopher at Medici court. So Renaissance is linked with Medici family, and Medici family, all of them were supporters of all these intellectual, artistic, scientific, technological activities. Uh, uh, a couple of months ago, I was in Galileo's museum and just looking at all these uh, devices ordered by Medici family to be made, and amazing measurement tools there, amazing what called sighting tools, astronomical tools, and some of them never practically were used because they were so interested in making new stuff, and they paid to make all these stuff that you find out a lot of new instruments there, they didn't have a chance to use them, or they just made them to see if it is doable or not, if these new instruments have higher precision or accuracy or not. Anyhow, that period is very, very interesting, which created too many thinkers, from Machiavelli to Michelangelo to Leonardo da Vinci to Galileo. Okay, we talk about Galileo here. Galileo was hired by Medici as court mathematician, but Galileo bargained with them to add philosopher also to the title, because again, still that hierarchy was there. Philosophers were the most eligible people to talk about, I don't know, big stuff about the structure of the universe, about new ideas, new models. And since Galileo had new ideas, he needed this title. And he was a very respectable, at the same time, very revolutionary and odd person. And he was not the inventor of telescope. These are the original telescopes that he made, the samples that we have. And here you see the one of the broken lenses that he had. Galileo was a very good lens maker, lens grinder. You see that, you know, even now, we, to make very precise lenses, you have to grind lenses. You cannot cast them. Only cheap lenses or concave mirrors can be cast, or you just mass produce them. But for very precise lenses, you have to grind them. And it is simple. If you are interested, you can buy the kit for that. Check Amazon, you can find the entire kit. Long ago, I had an astronomy class, and we made 13 telescopes in one semester. So you buy these blocks of glass, Pyrex glass, and that time they were using sand, but nowadays you can buy the entire kit. You put sand on top of the first glass, the first disc of glass, and there is another disc, and you rub them in a zigzag form and turn around the uh, platform that you have. Usually they put it on a stool, and then they rub it with a pressure, with a constant pressure, and circle around that. After a while, the top glass turns into concave and the bottom glass turns into convex, and then continue it. And there are a lot of what's called experiments and material to polish them, and at the same time control the curvature of the lens. Anyhow, this is a different story. He did not invent telescope. The telescope was invented by Dutch people, and it was used in military mainly because they used it to spy, I don't know, the fortifications of enemies, their fleet, or their troops. Galileo learned about this, and since he was a lens maker, he knew about optics. That time we were not that clear about the laws of refraction or reflection, but by examining different lenses, he was able to make the first telescope with a lower magnification, and then he increased the magnifications, and finally he was able to start his telescopic observations. But before uh, this, Galileo had uh, his new ideas in physics in motion. Uh, he started his telescopic ideas, observations in 1609 to 1610 and continued after that. But in 1590s, almost 20 years before that period, he started to examine free fall and uh, what to verify the validity of ideas of Aristotle. He was in a big part non-Aristotelian thinker. And what we call it local motion. Local motion means that you have, I don't know, free fall and you drop it. Aristotle had his own physics in this way. I already talked about this, that this ball falls not by force, by its nature. Because it's heavy and its natural place is ground, you lifted it. It didn't. It was not here. You lifted it, and it should go to its natural place, and it moves downward by its nature. And when you have a smoke, the smoke goes up because of its nature. How about projectile motion? It says that when an object is moving, it moves in a medium because Aristotle didn't believe in vacuum. What are you talking about? There's nothing. When there's nothing, then what are you talking about again? Nothing doesn't have any meaning. A vacuum doesn't have a meaning, and vacuum cannot happen in nature. Then when you have a projectile motion, for example, I shoot this marker, when it moves, it rarefies or it creates a kind of vacuum behind, then air rushes behind that and pushes it. And the same thing happened in water, okay? And after a while, a friction and then this vacuum behind that just is filled and then object falls. And that's why projectile motion is not a natural motion. It is a violent motion. It doesn't last forever. It falls down because the combination of these, what we call forces, cancel out each other and it falls down. Aristotle's other idea, which is very interesting, that was not criticized for a long time, was about the ratio of free fall. In other words, the speed of free falling objects. He says that if you have an object which is 100 times heavier than another object, imagine you have a brick which is 10 kilogram, and you have another brick which is 1 kilogram. This brick is 10 times heavier than the other. Aristotle says that this heavy brick falls 10 times faster than the smaller brick. Galileo criticized this idea, and later in his book about two new sciences, which we're going to talk about this probably after the break that we have, he says that, okay, we don't see such a thing in our daily life. You drop a big stone and a small stone, they reach to the ground at the same time. Probably if you drop, I don't know, a feather or a piece of, say, fabric and a stone, obviously stone falls faster. because of what? This fabric or this tissue or a feather, it has a lot of friction with air. But when they don't have that friction and they are heavy enough, they fall at the same time. So he uses a combination of thought experiments and real experiments. There is a legend, it actually appeared later, that Galileo climbed this Leaning Tower of Pisa, and from there, since it is leaning, this is a real picture that you see here. It is lineage is about 5 degrees. They controlled it in there was a big project from 1990s to 2010. They controlled the leaning of this tower. And if you stand here, you drop balls, then you can see that they reach to the ground at the same time. So it says that with his assistant, he practiced this use of what? Experiment to verify something. This is very important. This is the core of modern science. Instead of sitting for centuries, I'm not talking about weeks or months, and for centuries you talk about the nature of things, that comets are not celestial, they are terrestrial, then centuries people thought about this. But now you sit an experiment and do it in 5 minutes, 10 minutes, or I don't know, a day, and you come up with a conclusion. This is a major change, how to we verify scientific statements. So we see here that Galileo criticized Aristotle by doing real experiments and by thought experiments. Again, in his book, Two New Sciences, he asks the Aristotelian guy that really, do you see such a thing in from your experience? You have a very big stone and you have a little smaller stone. You drop them, even in your imagination, they're gonna get the ground at the same time, and the other one is not falling 10 times faster, because 10 times a big time. You can immediately realize that, and we have not encountered with such a thing. So Galileo, after making his telescope, we're going to come back to his mechanical ideas about his physics after a few slides. He started telescopic observations in 1609 and 1610, and after that, at the end of 1609 and beginning of 1610 is a very crucial period in history of astronomy and history of science, because he revolutionized our idea about everything, and mainly in astronomy. So when you buy a telescope, even now you can buy a telescope from Walmart, and the first thing that you observe is the moon. By the way, I have to put my astronomer hat. I practice astronomy for a long time. I don't use any telescope, any binocular, anything carrying a lens to observe the sun. It seriously damages your eyes, and even it can make you blind, because it concentrates light, specifically ultraviolet, in the retina of your eye. And since we don't have nerve system there, it burns practically the retina, and you realize it after you end your observation. Anyhow, he damaged his own eyes also, but he was clever enough to invent a new way to project the image of light, image of sun on a piece of paper. At the same time, he made the first filter to observe the sun. He put a piece of glass on a candle and covered it with soot, and used it as a solar filter. Anyhow, he observed the surface of the moon with this telescope. And what did he observe? What did he see? He saw mountains, he saw plain areas, craters there. This crude telescope actually showed those plain areas. He thought that they were uh, oceans and seas. That's why he called them mare. Still, we call it in Latin mare, or sea. Now, let's stop here and think just a few minutes about this. You have this telescope, and before using that, what was your idea about moon, the nature of moon? Based on Aristotle and then university education that you have, a scholastic philosophy, religion, moon was a celestial object. And all celestial objects were made up of what? Ether, the most perfect substance in the universe. So it was a different story. People that time ask why then we have those what call spots on the moon. Some parts are very bright, sometimes are not. There was a long story about this. People were thinking that in some parts we have a concentration of ether, in some parts not. I don't want to enter there, but for everybody that time, moon was a celestial object, and it was made up of ether, a pure substance. But now you observe the moon for 5 minutes and you find out that there are mountains on the moon, there are plain areas, there are craters on the moon, and moon is pretty much like the Earth. We're going to talk about it again more and more because it was not a simple observation. Galileo was a very smart mathematician. And as we will see, he used the length of the shadow of these mountains on the moon to calculate the height of the mountains. He came up with a lot of new ideas, and he proved that by observation that the moon was a place like the Earth. So little by little, we enter into an atmosphere, intellectual atmosphere, to break this idea that we have celestial region and we have terrestrial region. Based on Aristotle, nothing is changing in celestial region. The second discovery that Galileo had was about sunspots. Again, I'm repeating, don't look at the sun with a telescope. Galileo projected the image of the sun on a piece of paper, and he found sunspots on. What are sunspots? They are dark spots on the sun, and they are moving, and their size is changing, their location changes. Based on modern astronomy, we know that there are spots which the hot material from the inside of sun, for some physical reasons, cannot easily come to the surface, and those parts are a little cooler than the rest of the sun, or the surface of the sun is 6,000 Kelvin, but those parts are about 4,000 Kelvin. They are 2,000 degrees less than the rest of the surface, and we see them darker than the rest. Anyhow, this is modern astronomy. But what was the observation? You find dark spots on the sun. They are changing in size and shape. Their location is changing. And after a while, he discovered that they are moving in one direction, and it seems that the sun is rotating. Okay, it is a revolution in our understanding of celestial objects. First of all, there is change in celestial region. The best astronomical object that we had was what? The sun, the source of life, the source of light that God created for the entire universe. And then it is not perfect. There are spots changing, and it is rotating. Okay, and Galileo was smart enough to find out that the rotation of the sun takes about 30 days. The same time, a British astronomer named Christopher Scheiner did similar observations because telescope became widespread and everybody knew about that. And he said that, those spots were not a part of the sun. They were not attached to the sun. They were actually clouds, dark clouds above the sun, and they are not a part of this most perfect object that we know in the sky. Again, Galileo was smart enough to prove that they were attached to the sun. First of all, it showed that over and over that the rotation of the sun is happening, and they are moving pretty much with the same. So if they are clouds above that, how come that they rotate with the same rate? The second thing that he discovered, he pinpointed a, say, circular spot, and when it moves with the sun and reaches to the limb of the sun, the edge of the sun, it turns from circular to elliptical, and it happens only if it is attached to the sun. If it is a piece of cloud, it can go away without changing in shape. And it was another proof that the sun was, the sun had these spots, it is changing, and it is not perfect. Then, first observation of the moon showed Aristotle was wrong. All religious authorities were wrong. All philosophers that we had before were wrong. And the same thing about the sun. Sun is not perfect. It is rotating. Nobody know about that. And we have change on the sun, on the surface of the sun. And it means that Aristotle was wrong. Okay, folks, let's stop here, have a break of 10, 12 minutes and come back later. So grab a coffee or take a rest, and